Hi there, in this video clip today I want to talk about gases and in particular quantities of gases. These are measured in the terms of moles. In a previous video clip I said that if I took a mole of a substance, and that could be a compound, a mole of atoms, molecules, etc., they contain the same number of molecules or atoms or ions. And if I took 1 mole of a gas, it occupies the same volume. 1 mole would simply be the molecular mass of a gas expressed in grams. Let's look at what I've just said. If I took 1 mole of hydrogen gas, 1 mole of carbon dioxide gas, 1 mole of oxygen gas, the relative molecular mass of hydrogen, H is 1, so it's 2. The relative molecular mass of carbon dioxide is C, 12 plus O times 2 is 44. And 1 mole of oxygen gas, its relative molecular mass is 32. So 2 grams of hydrogen is 1 mole, 44 grams of carbon dioxide is 1 mole, 32 grams of oxygen is 1 mole, and 1 mole of gas occupies 24 dm cubed. It's a constant, it's fixed, so 2 grams occupies 24 dm cubed, and they all, 1 mole of the gas, that's its weight, occupies 24 dm cubed. Just to remind you, how much is 24 dm cubed? It is equivalent to 24,000 cm cubed. Right. Let's look at an example. I've said 1 mole of a gas occupies the same volume, which is 24 dm cubed. Let's go back to carbon dioxide. It's 44 grams. So suppose I said I've got 88 grams would be equal to 2 moles, which is equal to 2 times 24, which is 48 dm cubed. Easy, eh? Or let me write it in an equation form. The number of moles equals the relative molecular mass. No, it's not. It's equal to the mass of the substance divided by the relative molecular mass. Let's go back to carbon dioxide again. If I've just done this, but I'm doing it again. Suppose I got 88 grams divided by 44 is equal to 2 moles of carbon dioxide gas. Let's look at another. Like I said, these do give students a bit of grief, so I'm going to labour the point and go through it quite slowly. Here's a well-known equation now, which we've spoken about, Mg reacting with hydrochloric acid, HCl, to give me magnesium chloride and hydrogen. Suppose, for example, I've got 3 grams of magnesium and I want to calculate how much hydrogen gas is produced. look at that equation. 1 mole of that plus 2 moles of that gives you 1 mole of that plus 1 mole of that. I've got 3 grams of magnesium. The relative molecular mass of magnesium is 24, so I've got 3 over 24 moles. And guess how much hydrogen is produced? It's going to be the same, 3 over 24 moles. So, and I could have said how much hydrochloric acid is going to be used. It would be twice that amount of moles. So I've now known I've got 3 over 24 moles of hydrogen. That cancels out, by the way, and that is equal to 1 over 8, which is 0.125. I know I've got 0.125 moles of the hydrogen. How much is that then? What volume would it occupy? I know this, that 1 mole occupies 24 dm cubed, so therefore it's going to be an eighth of that, which is equal to 0.125 is an eighth times 24 is equal to an eighth. I'm doing this in longhand, labouring it, and that goes 3 times, so therefore it occupies 3 dm cubed. I've been through it quite slowly, and basically the only stuff you have to remember is how many moles are there, and don't forget the equation. The number of moles is equal to the mass of the reactant of the substance divided by the relative molecular mass. We're almost there now. Like I said, this subject does cause people a bit of grief. Now, I can use the principle of moles to balance an equation. For example, methane gas reacts with oxygen, easy peasy, to form carbon dioxide and water. It's not balanced. And suppose I had 8 grams of that and oxygen, 32 grams of that, reacts to form 22 grams of carbon dioxide and 18 grams of that. What I'm going to say here is I've done that experiment in which I took 8 grams of methane gas, burnt it or reacted with 32 grams of oxygen, and the products were 22 grams of carbon dioxide and 18 grams of water. Let's calculate the number of moles. Number of moles, 8 divided by the molecular relative formula, that is 16, and that would be 32 grams divided by the relative molecular mass of oxygen gas, O2, is 32. Carbon dioxide is 22. The relative molecular mass of carbon dioxide is 44. Water, H2O, 18 divided by 18. So that number of moles plus that number of moles gives you that number of moles. That is 0.5. That is 1, that is 0.5, and that is 1. So you can see there, if I multiplied it up to get me a whole number, I'd get 1, 2, 2. I know I've made a mistake there. Sorry, that would be 1.5. Sorry, that would be, multiplying up would be 2. So therefore, when it comes to balance that equation, it's only one of those. There's going to be 2 of those there, 2. Once, and there it's going to be 2 there, because 1, 2, 2. Sorry, that is wrong. Stupid boy, that is 1, and that is 2. Even I made a mistake there, but if you know the relative molecular masses and you can calculate the number of moles of them, you can also then work out to balance the equation. Okay, that's it, folks. Like I said, there's a bit of maths there involved, but it's not too difficult. Talk to you again.